Hi everyone, today we will discuss the arcsine function. Arcsine, the same notation, arcsine is an inverse sine function. Do you remember inverse function? If you have a input value x, now output value is y, let this is the function f, then inverse means if you simply switch the direction of an arrow, this is the inverse function. Okay, so all input value will be switched to output value and all output value will be changed into input value. Okay, so to have the inverse function, our original function must be 1-to-1. Okay, otherwise our inverse function is not possible. But think of sine graph. If I draw roughly, sine graph is here, right? So definitely this is not this is not one-to-one function. So to make an inverse function, we will choose only some interval that is the one-to-one. So from here to here only. Okay, that is the rule, or that is the promise. So from this picture, this is a negative pi over 2 to positive pi over 2. Okay. Now this is the sine of x. If I restrict our domain from negative pi over 2 to positive pi over 2, or in degree mode from negative 90 degree to positive 90 degree. Okay. Now inverse of this one is here. Okay, this is our inverse function. Our domain of inverse starts from negative 1 to positive 1 only, and the corresponding y value will be here, negative pi over 2 to positive pi over 2. Can you see that? These two graph, everything is switched. So if I draw a small rectangle for reference purpose, the sine function will be defined only on this interval from negative pi over 2 to positive pi over 2. The reason is we need a one-to-one function. Okay, then the inverse function will be here. Okay, then your input value of y equals arcsine from negative 1 to positive 1, and the output value will be from negative pi over 2 to positive pi over 2. Can you see the relation between these two graphs? Okay. Now look at this. In sine function, input value is the angle, right? Sometimes degree, sometimes radian, but anyway, sine or both something is angle. And the result is the value, right? But in arcsine, the inverse function, please note that the angle and value position will be switched. Okay? So for example here, in regular sine 30 degree will be 1/2, for example. Okay, But in arcsine of some value, result is a degree. Sometimes radian, sometimes degree, it doesn't matter. But anyway, angle. Okay? And we must understand this table very, very carefully. Look at this. Sine 30, or in radian mode, sine pi over 6 is 1/2, which means about here, this is a pi over 6. Now this is 1/2. Okay? Now next one, this one, sine 150 is also 1/2. Sine 150 or 5 pi over 6 is about here. If you move to the y-axis, this is also 1/2. And next one, sine 210 or sine 7 pi over 6, that is about here, 7 pi over 6. Now corresponding function value is here. Now what is the function value? Negative 1/2. Okay? And last one, sine 330, about here. Now this is also negative 1/2. Okay? I think everyone can understand this picture already, but the key point is on the right side value. Let me erase this one. Okay, look at this. They ask arcsine 1/2. Okay, arcsine 1/2. If we look at this part, the two different angles has the same sine value 1/2, 1/2. But we will use only pi over 6, okay, not 5 pi over 6. Why? Because we defined our inverse function only in this highlighted interval. Okay, although I sketched the sine, not arcsine. Here, look very carefully. Arcsine of 1/2, yeah, 1/2 is here. Now, what is the x value? Here, pi over 6. Okay. If you move continuously, you have a 5 pi over 6. And since this is a periodic function, we have so many possible answers. But when they ask arcsine, we use only this part. Okay? We must understand this concept very carefully. Otherwise, when you use your scientific calculator to find some angle using arcsine, you may be confused with the result. Your scientific calculator for arcsine of something always give you the angle from negative 90 to positive 90 only in degree mode, or pi over 2, negative pi over 2 to positive pi over 2 only. Okay, no exception. Now, same reason. They ask us what is the arcsine of negative 1/2. Negative 1/2 is here. So corresponding function value is here. Now we will move backward. What is this? That is a negative 30 degree. Okay? Or negative pi over 6 in radian mode. Good? Please invest some of your time to understand this concept. Okay, we will practice only 2 more questions. find the value of each expression. Arcsine radical 3 over 2. Let me sketch the sine function, not arcsine function, because in most cases arcsine function can be a little bit confusing. So you can use just sine, but please restrict our domain here. This is the x-axis. This is the y-axis. I will make a grid. This is 1. This is -1. This is a negative pi over 3. Sorry, pi over 2. This is partially pi over 2. Yes, our graph exists in this box only. This is 1, -1, minus pi over 2, positive pi over 2. Okay, how can you sketch the sine? Sine is here. Okay, since they ask us arcsine, we will start a value on the y-axis. So since square root of 3 is about 1.732 over 2 is about 0.8 something, right? So very close to 1 here. Now please try to find the point on the graph. Now this is the answer. Okay, we must find this one as our answer. To find the value or exact angle, I will use the triangle. I believe you are very familiar with this one. From 0 to 90 degree, yes, first quadrant angle. Sine is opposite of hypotenuse. Opposite of hypotenuse is a radical 3 and 2. So please note that this is reasonable to sketch the triangle like this one, right? This is a radical 3, this is 2. Don't sketch your triangle like this. Okay? This looks like 1 and 2. Indicates this is 1, this is radical 3. Okay, now this is a special triangle, right? What is the angle of this one? 60 degree, right? Or in radian mode, you have pi over 3. This is the answer of this one. Okay. Now with the same picture but different value, let me sketch one more time. X-axis, y-axis. I will draw a grid box. This is a negative pi over 2. This is positive pi over 2. This is 1. This is a -1. Your graph is here. Now your value is a negative square root of 3 over 2, which is here. Now corresponding function value is here. Okay, this is your answer. Now again, I will sketch the triangle. From your angle is here. From -90 to +90, which means your angle exists in fourth quadrant, right? And in fourth quadrant, please sketch a triangle whose sine value is minus radical 3 over 2. So with a very similar reason, this is a reasonable picture, right? Again, Don't sketch your picture like this. Otherwise, you will be confused with your own picture, because it can be easily read as a 30 degree. But our answer is 60. Basically, negative 60 degree, right? Here. Or negative pi over 3. Here, one more key point. For this angle, don't say 300 degree. Okay, although they have the co-terminal. Here, let me add some more. Sine negative 60 is a minus radical 3 over 2. Sine 300 degree is also minus radical 3 over 2. But if I ask you what is the arcsine negative square root of 3 over 2, then answer must be this one. Okay? Please note that this is a negative 90, this is a 0, this is a positive 90 degree. So your answer in arcsine must be a number always greater than negative 90 and less than positive 90, or y equal to. Okay? One more time. Y equals sine over x. Now inverse of this one will be y equals arcsine over x. If I sketch this one on the same plane, for sine, here, okay, this is sine over x. Now, how can you sketch y equals arcsine over x on the same plane? We must sketch a new grid. Please note that their dimension is slightly different, because pi over 2 is about 1.7, right? Or 1.6 something. So slightly greater than 1. Now on this plane, on this grid, we can sketch this one, which is here. Okay, can you see that? And one more thing, so if these two functions are inverse each other, they always must be symmetric over the line y equals x. Okay? Okay, thank you for watching. I hope we can see you next time. Bye bye.